Okay, this is a lesson on solving word problems using systems of equations, and we're going to start with this geometry problem. What we have here is the length of a rectangle is 3 feet less than twice its width. If its perimeter is 48 feet, find its area. So what I'm going to do right here is I'm going to say let W equal the width, and I'm going to let, just so those L's don't end up looking like ones, I'm just going to let Y equal the length of the rectangle. So that's width of the rectangle and length of the rectangle, and this is both are in feet. All right, so first of all, what we know is that 2 times W, so the first equation in our system is about perimeter, that 2W plus 2Y equals 48. That's about, there are two widths and 2 lengths, and we know that sum is 48 based on what the perimeter is 48. And then it says the length of a rectangle is 3 feet less than twice the width. All right, so we're going to say that Y equals 2W minus 3. And you can see that this sets up nicely for substitution. We just draw that's our system. And so what I'm going to do is I'm going to replace this for the Y right there. And so I'll say 2W plus 2 times 2W minus 3 is equal to 48. So that's 2W plus 4W minus 6 equals 48. And I get 6W minus 6 equals 48. I'm going to add 6 to both sides, and that will get me that 6W equals 54, and divide by 6, and I get W equals 9, and that's in feet. And then I know that the length is equal to 2 times 9 minus 5, so that's 18 minus 5, which is 13. So it's a 9 feet by 13 feet rectangle. All right, let's look at the next one. So this next problem, it's an investment problem, and I have that Bill invested some money at 5% interest, and Jeanette invested some at 7%. If their combined interest was $310 on a total investment of $5,000, how much did Bill invest? So I'm going to let X equal the amount of money that Bill invested, and let Y equal the amount of money that Jeanette invested. Now the first equation is just about their total investment. We know that X plus Y, the amount of money that Bill invested, the amount of money plus the amount of money that Jeanette invested, totals $5,000. And then what we also know is the amount of interest that was earned. So if we say 5% on the amount that Bill invested plus 7% on the amount of money that Jeanette invested equaled $310. So so there's our system. Again, this shapes up pretty well to use substitution. So if I say x equals, well, let me just go ahead and not rush that. I'll say x plus y equals 5,000. So if I subtract y, I get that x equals 5,000 minus y. So then I'll take that and I'll substitute this up into x right here. Got to go into the other equation, and I'll have 0.05 times 5,000 minus y plus 0.07 y equals 310. And so 1% of 5,000 is 50, so I'm going to have 5 times that, so $250 would be 5% of 5,000 minus 0.05 y plus 0.07 y equals 310, and then that leaves me with 250 plus 0.02. And that will equal 310. I'm going to subtract 250. And I got 0.02y equals 60. Now remember that 0.02 is 2 100ths or 1/50th. So that's 1/50th y equals 60, multiplied by 50 on both sides, and that's y equals 3,000, and we know that the total was 5,000, so that's going to remind us that, so remember y was Jeanette, so Jeanette invested. So Jeanette invested, and this is Jeanette, and then that means that x equals, since the total was, and that's Bill, so that's the amount of money that each invested. Oh, so it asks about Bill, so since it asks how much did Bill invest, this is what we wanted, this one right here. So that's what I really should have circled there. Okay. Now we're next going to look at a mixture problem, and these are probably the most challenging, but there's really one issue here that's the most significant that we'll need to think about, and I'll make sure I point that out. So you basically have, think about let's draw a little picture here. So I've got a solution that I'm gonna, let me draw it actually the other way. So I got a solution that I'm going to pour in here. This is so this first, you have a 40% alcohol. So think of a solution. So what that means is that 40%, just think of it as 40% of it is alcohol and the rest of it's water. All right, and that is being put into this mixture here. And so that's going into there. And on the other side, you have another type of solution. And this one is 55% alcohol. So that's going in there to make this mixed solution. And what this says is the mixed solution is 50%. So what that would tell you, since 50 is closer to 55 than it is to 40, that we're going to have more of this in there because 50 is closer to 55. So that just gives you an idea. We know that the total that's going in there is 15 liters, and so let's define our variables as let's let x equal the number of liters of the 40% alcohol solution in the mixture. And let y equal the number of liters of the 55% alcohol solution in the mix. So my system of equations is going to be, first of all, just about the mixture equaling 15 liters. I have some number of liters of the 40% alcohol plus another number of liters of the 55% alcohol solution, and that totals 15 liters. Now the second equation is about the content of alcohol within each. I have 40% of the 40% alcohol solution is alcohol, and I have 55% of the 55% alcohol solution is alcohol in that mixture. And of that, here's the tricky part. I want a result being of 0.5 of the 15 liters. So the second equation is about the content of alcohol. This is about the content of alcohol. This is just the mix of the two solutions totaling 15. So that's what we always want to think about in mixture problems, to really be set up like that. But remembering that this is key. I can't set this equal to, I can't set an amount of alcohol that's also in liters equaling a percentage. I have a percentage of what? A percentage of 15. So that's why that sets up that way. All right, so we can use, so just to play it different, I'll use elimination on this one just to be different, but I could certainly have used a substitution again. So I'm going to multiply by, so I'm taking that first equation and I'm multiplying by negative 0.4. And so number 4, and I'm going to get negative 0.4x plus, or let me just say minus there, minus 0.4y equals, so that's 40% of 15, or 2/5 of 15, which is negative, so negative 6. And then I'm going to stack the other equation, and that would be 0.4x plus 0.55y, and up here we have 0.5 of 15 is 7.5, so that's going to go here. And then I'm going to add all of this to the left side and add 7.5 to negative 6, and that will get me I'm going to get 0.15y equals 1.5, and 15, so that's 15 100ths y equals 3 halves. So that's divided by 5 is 3 20ths y equals 3 halves, multiplied by 20 over 3, and those cancel, so I get 10. So y equals 10 liters, and a reminder what that is up above. That is so the y is the 55%. Remember we said there'd be more of that, and so that's the 55% solution. And the x is, remember the total's got to be 15, that's the 40% solution in the mix. Alright, so this is an integer problem. So in this one I have 3 times one integer plus another integer is 29, and now these are not consecutive integers, it says 2 integers. If the first integer plus twice the second is 18, find the integers. So we'll keep our variables as x and y. Let x equal one of the integers, and let y equal the other integer. So we don't have to worry about consecutive, even or odd, or just consecutive integers, just 2 integers. So it says, so let's just turn the words into an equation. 3 times one integer plus another integer is 29. So we'll say 3x plus another integer is 29. So that's one of our 2 equations in the system. And then the other one says if the first integer plus twice the second is 18, find the integers. So we'll consider x to be the first integer plus 2y equals 18. Now we have our system. So let's multiply the first equation by -2 to get the y coefficients to be opposites. So that gets me -6x minus 2y equals -58. I'm going to bring the other equation down to stack underneath that. So that would be the second equation in the original system. So I have x plus 2y equals 18. And I'm going to add that there and add this here. And I will get -5x equals -40. Divide by -5, and I get x equals to 8. And then if I just plug into either of those, if I take this and plug it in right here, I'll get 8 plus 2y equals 18. So -8 minus 8, and I get 2y equals 10. And so that will get me that divide by 2, and I'll get y equals 5. So let's stack that right there. So those are the 2 integers. Okay, last problem. So this is a pretty traditional system of equations word problem. And so what you have here is 2 partial recipes for paint supplies appear in the illustration. How much did each gallon of paint and each brush cost? So it says that, so you can see that the missing is what these cost, And we're going to figure that out because we have these two scenarios here that give us a system of equations. So, so in this one deal, you have 8 latex gallons of paint and 3 brushes cost $135. And the other one's 6 latex gallons of paint and 2 brushes cost $100. So let's get our variables defined. Let X equal the dollar cost of a gallon of latex paint and let Y equal the dollar cost of a paintbrush. So the first equation is 8x plus 3y equals 135. Second equation, 6x plus 2y equals 100. I think I'm going to work on the y coefficients. So if I have 8x plus 3y equals 135, I'm going to multiply those by 2 on each side, and that will get me 16x plus 6y equals 270. Let me take the second equation and multiply by -3. And that would get me, I'll write that down here, -18x minus 6y equals -300. Add this to the left side of the first equation, add that to the right side of the first equation, and I will get -2x equals -30. So divide by -2, no, not -300, -30. And that will get x equals $15. And and then I can plug that into either of the equations. So each brush costs $15, and so if I go 8 times 15, let me use the other equation, numbers are slightly easier. So if I go 6 times 15 plus 2y equals 100. Equals 100. I'll have, so 6 times 15 is 90 plus 2y equals 100. So subtract 90 and you get 2y equals 10. So that means that the paintbrushes were $5. So this is the paint and the gallons of paint and the brushes. And so let's write that in there. Okay, and circle that, and that is the end of the lesson.